Okay, the last few days we've spent time with sine and cosine functions. Now we're going to do the last one, which is going to be tangent functions. Okay, we'll talk at the end about cotangent, cosecant, and secant, but for the most part, you don't have to worry about those. You really just have to worry about the three main ones. Okay, you have to worry about sine, cosine, and tangent. So the reason why we spent so much time on sine and cosine is because it'll make tangent so much easier. And to be perfectly honest with you, tangent is probably the easier of the three. Okay, because it's basically in sections of graphs. Okay, it's going to look the same, but instead of it being like that continuous curve, I think it's easier for students to see with tangent because it's like you see individual graphs instead of one continuously flowing line, okay, whether it be sine or cosine. Now, there are some major differences, but realistically there's not a whole lot of difference as far as what you've got to do to graph these. Instead of with sine and cosine and the period normally being 2 pi in length, tangent has a period length of pi, okay, as far as your original. Now, a lot of times this will change, just like sine and cosine did. You can change your period length very easily, okay, just like we did before. Tangent function is odd, just like sine is, so that means if I plug in a negative value for x, it's going to give me a negative value for y, and vice versa. Okay. Tangent, the difference between tangent and sine and cosine function is sine and cosine functions just continue to flow as far as my domain is concerned, where tangent functions are going to get broken up. Okay? They're going to have asymptotes. Because remember that sine and cosine, or excuse me, tangent is just sine over cosine. So then in certain places, if tangent of theta is equal to sine of theta over cosine of theta, there are basically two spots where our sine value is a 1 and our cosine value is a 0. Or our sine value is a negative 1 and our cosine value is a 0. What's going to happen basically at these two spots? Can I ever divide by a negative? No. Okay? That's where the undefined part comes in. Okay? At pi over 2, which is basically on the two spots on the x-axis, either on the top side or, excuse me, on the y-axis, but at 0, when x is at 0. Okay, so at that positive 1 and that negative 1 side, it's not going to have a value. It's going to be undefined. Okay, because it's going to be 1 over 0 or negative 1 over 0. So the reason why then it's not going to have a period length of 2 pi like the full circle, because at two different spots it basically cuts the circle in half. Okay, it cuts the circle in half at the y-axis. The reason why it repeats is going to be because if I have two values in like my first quadrant, okay, if we go kind of off of what's going to happen here at those two spots? Sorry about what's going to happen in the first quadrant and the third quadrant? What's our tangent value going to be? Positive. What's going to happen then in the other two? It's going to be negative. Okay. So you're going to have the same values, that you can have the same x values, you could have the same y values, whatever, that it's just going to continue to go. So there's only two parts that is going to cut your normal period in half. Okay? So whenever we do this, it's really pretty it's really a pretty simple graph in terms of you're going to have two asymptotes. It's going to look like a cube function is really what it's going to look like. Okay. Cube function, if you look on, I don't have one, do I? No. Okay. It's basically going to start on the left side. Normally it's going to start on the left asymptote. It's going to go through and it's going to go towards the right asymptote. The left side, normally, if nothing changes as far as a negative or things like that, the left side is going to go to negative infinity. The right side is going to go to positive infinity in terms of my range. The one thing that you've got to pay attention to is whenever we talk about kind of it gives you your window. So what that means is, like, after you are given your function, it'll tell you how much to graph. So like on the first one where it says y equals tangent of x, and it wants you to show from 0 to pi over 2. That's all you have to show. So whatever your window is, that's how much you graph. You may have only one function in there. You may only have half of a function. You may have 2 or 3. It just depends on what you're dealing with. But whatever's at the end, it will tell you what your window that you're dealing with and how much you need to show. Now, just like whenever we had sine and cosine, you had reference points. Okay? You essentially still have 5 reference points, just like we did with sine and cosine. Okay? With sine and cosine, we had the two ends of our graph. In some cases, it was 0 with sine. In some cases, it was 1 with cosine. Whereas here with tangent, your two endpoints are really, or your two reference points that are on the end, are really going to be your asymptotes. Just like we did with sine and cosine, once we found our two endpoints, then what did we do? How did we start cutting the graph? Yeah, we found the middle. We cut it in half. So the same thing's going to apply here. We have our asymptotes there in green. First thing I want to do is I want to cut this thing in half. Whenever I cut it in half, what's going to happen? Where's it going to cross in the middle of my graph? 0. Where do you think it's going to cross every single time? 0. Unless we shift this thing up or down, it's going to cross the x-axis. Unless there is some sort of vertical shift, just like there was yesterday. Same thing then applies. What did we do before with sine and cosine? We cut it in half, and then what did we do? We took a half of a half, right? So we're going to take a half of a half again. We'll make that blue. Where are those two values at? No, pi over 2 is my asymptote. Pi over 4 and like negative pi over 4 and positive pi over 4, right? Where's our actual y value though? 1 and negative 1. Okay? Now, why is it 1 and negative 1? Well, remember with your hand, what was this finger right there? Your middle one. Pi over 4, right? Remember, tangent, you have pi over 4, you have whatever's on top over sine over cosine, whatever's on top, you flipped your hand over. What's going to happen? You have 2 fingers on top, you have 2 fingers on bottom. What's going to happen to everything? It's going to cancel, and it's going to be a positive and a negative 1. Now, your right side will always be whatever number. Okay, so the right half of a half, or the right 3/4, is whatever number is in front of your tangent value. So if it's a 3, I'm going to go over to basically go to that 3/4 mark, and I would go up to 3. If it was a -2, I would go over to my 3/4 mark and I would go down to 2. Okay, so whatever value that's in front here, that's what the right side's going to do. The left side's going to do the opposite. Okay? I'm telling you, tangent is so much easier because you have your asymptotes, and the hardest part is going to be to find the asymptotes, and we'll do that in just a second. So then if you don't have that, or if you need to take a picture, or you need to write that down, So the biggest thing that you have to worry about with the transformation is figuring out where your asymptotes are. That's it. Once you figure out where your asymptotes are, then it's just a matter of what's halfway, what's a quarter of the way, or what's the half of the first half, or what's the half of the second half, and the 3/4 of the way of your graph. If normally your asymptote starts at -π/2 and then π/2, all you're going to do is take whatever value is on the back end. So after it says tangent of whatever it says, and you're going to have x somewhere. You may have a plus, you may have a minus, all of that. You're going to set each one individually equal to -π/2 and π/2. So this part right here. Once you find your asymptotes, the rest of this thing is as easy as can be. Or it should be. Because you're just looking for halfway and boom, you're going to put a point at 0. Once you find your asymptotes, then again, you will find the halfway point of wherever those two values are. And that's going to have, you're going to have a reference point on the x-intercept right here. Your other 2 points that you're looking for are all dependent on whatever your a value is. Whatever your a value is, that's going to go on the right side. The left side is just the opposite of it. Okay? So the left side is the opposite value. So if it's a negative, you're actually going to be up top at a positive. If it's a positive, like it's going to be most of the time, you're going to go down to a negative on the left side. And then the right side, it is what it is. If it's a 3, if it's a 5, if it's a 1/2, you're going to go to that value, and then you're just going to connect your line and just draw a simple curve. So then, whenever we graph this thing, if you have to put your graph together, or if they give you a graph and you maybe don't know, well, how long do I need to make this thing? Well, normally, the first thing I want to do is check here. Okay, what do I have to count by, essentially, and go from there? It's going to go from -π all the way to 3π. Now, just like everything else, so if I'm going to go from -π, I'm going to call that -π. I'm going to go ahead and have a reference point of -1/2 pi. And then everything else is going to go, so there's going to be pi, 2 pi, halfway again, and then 3 pi. Go ahead and give yourself reference points for what it wants as far as your window is concerned. Always check the window as far as how much of your graph does it want. It may have one value, it may have one set in there. It may have 2, it may have 3. Okay? But just know that this is what I've got to put on here from my lowest value to my highest value. Okay? They're not really worried, or we're not really worried about anything in or outside of that window. You could definitely draw more if you needed to, but it's not something that you have to do. So once you figure out your window, then it just becomes, hopefully, fairly simple. I'm going to take everything that's on the back side of my tangent value. So I have y is equal to 2 times tangent of x over 2. So I'm going to have two problems. I'm going to have negative pi over 2 equal to x over 2. And then I'm going to have pi over 2 equal to x over 2. What do the two red equations mean? What am I looking for with those two values? My asymptote. So then, hopefully, this one's pretty straightforward and pretty easy to hopefully understand what my two x values are. Okay, because they match perfectly. Now, if you need to do the math side of it and you need to multiply that side by 2 and this side by 2 and get negative pi equal to x, and then do the same thing over here and get pi equal to x, that's going to be my asymptote. Now, since it's from negative pi to pi, and I have a window that goes from negative pi to 3, what do I need to keep doing? Do I need to have more than one graph? Yes. I need to show the other one. Okay? So, how long is my actual period? My period is normally pi over 2 to negative pi over 2 to pi over 2. This one goes from negative pi to pi. So it's actually 2 radians, 2 pi radians in length. If I'm going to graph this, what's the first spot that I need to find? What's the easiest spot to find? 0. Where's 0? Where's halfway of the first one? 0, 0. Now, if you want, you can draw the other one and just put it at 2 pi as well. Hey, if you want to do each one individually, I have no issue in that. You can do it however you want, whatever's easier for you. Now, what's my other two reference points for each graph? 2. How'd you get 2? That number right in front. The right side goes to 2. So 1, 2. Bottom side goes to negative 2. I'll do the same thing in each set, and then it's just to draw some pretty little curve. Try to go through your points if you could, unlike I did. Oh, I missed both of them. Yeah. My bad. So even like on one like 2, my window goes from negative pi over 4 to 3 pi over 4. It's completely up to you. Even if I just make it pi over 2 and then, or negative pi over 2 and negative pi over 4. And each mark is just pi over 4. Pi over 2 and 3 pi over 4. I have my window. I need to take negative pi over 2 and set it equal to 2x. I need to take pi over 2, set it equal to positive 2x. Solve for x. What do I need to do to both sides? Or to both problems? Divide each one by 2. So whenever I do, I'm going to have negative pi over 4 is equal to x, and I'm going to have pi over 4 is equal to x. Draw my asymptote. Then it just becomes halfway, halfway. Where's the right side going to go and where's the left side going to go? 3. So up to 3 is about halfway there, and then do the same thing on the negative side. Like if you do negative pi over 4 and pi over 4 and pi over 2 and 3 pi over 4, if you need to have another like little tick mark and have, 3/8, do that. Or you need to have an 1/8 or something along those lines. If you're just not sure, if maybe what you have, just add another, just cut it in half again. Okay, the values are going to be pretty easy to work with and pretty. Not basic, but they're definitely going to be pretty nice in terms of that. We don't have to worry about graphing these. I just want to make sure that you're aware. As far as, we're not going to graph any of the reciprocal functions as far as cotangent, cosecant, or secant. But it is good to know kind of what they're going to look like and how they're represented. Like what the period length is, what the domain, and what your asymptotes are, if you have any. Which on all of these, you will have asymptotes. Your cotangent, just like tangent, they're going to look very similar. What's the only thing different from a cotangent curve to a tangent curve? As far as what it looks like. Instead of from the left to the right and going up, what's it doing? It's going, right to left, or left to right, it's going down. Now, there is one thing that your period is still pi, but as far as where you start, it's not going to start at normally negative pi over 2 and pi over 2 as far as your asymptotes. Your asymptotes will start at 0 and then go to pi. Okay, it's the same length, but it's just shifted over to the right, essentially. Same way with cosecant and secant. Cosecant and secant are just like sine and cosine. It's just like if you see the dashed line, that's your sine curve. That is your cosine curve down with the secant curve. It's the peak or the valley, and it's just a parabola is all it is. Okay? Your asymptote is where it normally would cross at 0, just like tangent did, okay, or cotangent. Okay, you can't divide by 0. So what was 0 for a regular trig function is now an asymptote for your sister function or the inverse function. And then lastly, this just kind of represents all of them. So then if you want it, need it, have got to have it, as far as what your sine function looks like, what your cosine function looks like, how long the period is, what the range is, and what the domain is. Okay, those are, it's all of it right there for you.